All right, we're at our last of our 5 steps, the decision rule. So this is the problem we've talked about, and this is what we have so far in sort of summary form. Hypotheses, we have the alpha, we have the test statistic computed here. A special little notice here. Remember that when we actually computed the t-score, it was negative, but we ignore the negative sign. One reason, a way to think of why we're doing that is, remember that the t-table we're using, right, the t-table we're using, all of these values are positive. There's not a negative value in the body of this table. We could make a separate table using exactly the same values except they're negatives. If you did that, everything would be precisely the same from here on down. You would still get 0.02 greater than p-value greater than 0.01. Everything from here on down would be precisely the same with the negatives as it would be with the positives, rather than have two separate tables, both of which give you the same result. What we do is this. From this point forward in hypothesis tests, if the t-tango, if the t-score you find, if the t-score you find is negative, you ignore the negative sign. That is not the same as the z-score. Z, Zulu, Z. Recall that the z-table, we will use this in a different procedure later on. Recall that the z-score, the z-table, does have negative values and positive values, right? Negative values here, positive values here. So the Z, Zulu, the Z table, you do not ignore the negative sign. With the t-score, you ignore the negative sign. The reason the t-table doesn't also have the negatives is because the degree of freedom mucks up the work a bit. So that said, our t-score we computed was negative 2.222. We ignore the negative sign. The t-score we will use is 2.222, degrees of freedom of 43. Find the two values in the 43 degrees of freedom row between which this number falls, and from that we inherited 0.02. Remember, reverse the direction of the inequalities. 0.02 is greater than the p-value is greater than 0.01. Now, I mentioned this a little earlier. This is silly. I am unapologetic. This is silly. But a student used this a few years ago, and a couple other students caught on to it and said, oh, this makes it easier. And so this is from a student, so you can't trust it to be, well, I'll just say it is silly. However, it's correct, and it will help you remember things. This is the biggest, the middle size, the smallest. This is Papa Bear, Mama Bear, Baby Bear. There it is. Biggest, middle size, smallest, Papa Bear, Mama Bear, Baby Bear. For the decision, here's what we do. Go back to step 2 and find alpha. We have 0.05. Find in this string of inequalities, number 1, is alpha in the string? If it is, so much the better. We'll consider that here in another problem. In this case, 0.05 alpha is not in this string. But where would it fall? Remember, this is the smallest, this is the medium, this is the largest. Again, you can think percent. This is 1%, this is 2%. Where does 5% fall in this string? Well, clear, 5% is over here. So you insert alpha into this string of inequalities. Insert alpha into that string of inequalities, and we'll get 0.05 is bigger than all of them. This is alpha. Baby bear, mama bear, papa bear, and this is what the student used. Baby bear, mama bear, papa bear. This is big old grandpa bear. All right? This is bigger than all of them. So, is alpha bigger than the p-value? Yes. Is the p-value smaller than alpha? Yes, mama bear is smaller than big old grandpa bear. If it's over here, I think the student used, if it's smaller than baby bear, I think the student used embryo bear. So if you want to use that, that's wonderful. But in this case, grandpa bear is bigger than mama bear. So 0.05 is bigger than the p-value. Or the p-value is less than 0.05. P-value is smaller than 0.05. Here's our rule. The rule is reject the null hypothesis if the p-value is less than alpha. Why this is the case, we're going to not concern ourselves with that for now. But this is the rule. This is the rule that you embed into your brain. Reject the null hypothesis if p-value is less than alpha. Otherwise, your statement is do not reject the null hypothesis. Your decision at step 5 is always going to be one of two things. There are only two possibilities. There is not a third. There are only two possibilities. One of the possibilities is reject HO. The other is do not reject HO. If you ever write the word accept, it is wrong. The only two things you'll write is either reject null hypothesis or do not reject null hypothesis. Some people say fail to reject. That's fine. Reject or don't reject. Those are the only two possibilities. You either reject the null hypothesis or you do not reject the null hypothesis. You never say accept. You never say fall back on. You never say go with. You say reject null hypothesis or do not reject. And so, if in this case, here's mama bear, here is big old grandpa bear. Is mama bear less than big old grandpa? Is the p-value smaller than alpha? Yes, the p-value is between 1 and 2%. Alpha is 5%. Yes, in this case, p-value is less than alpha, so you reject the null hypothesis. Our statement for step 5 is reject the null hypothesis. We reject the null hypothesis in favor of the alternate. That means that based upon these data would lead us to reject the null hypothesis in favor of the alternate. These data support the alternate hypothesis. These data support what the researcher was trying to establish. Remember where this problem came from was this reaction time problem. The researcher believes that the mean reaction time is less than 59.2, and we have rejected the null hypothesis in favor of the alternate. These data support the contention that the mean reaction time is less than 59.2. These data support the alternate hypothesis. So reject the null hypothesis or do not reject the null hypothesis. Those are the only two, and this is the rule. Reject the null hypothesis if p-value is less than alpha. It is never correct to reference the alternate hypothesis here. Never, no matter how many times students try it, it's never correct. The only two decisions you ever make is reject the null hypothesis or do not reject the null hypothesis. It's not just a linguistic trick. It has to do with the logic of the structure we're putting together here. So, p-value 0.02 greater than 0.02 is greater than the p-value is greater than 0.01. Into that string of inequalities, insert alpha. In this case, that's here. 5% is greater than p-value, which is the same thing as saying p-value is less than alpha. Since the p-value is less than alpha, we reject the null hypothesis. If this is false, if the p-value is not less than alpha, then you would use the alternative. This is do not reject the null hypothesis. This is if the p-value is greater than or equal to alpha. If the p-value is the larger, you do not reject the null hypothesis. Reject the null hypothesis if the p-value is less than alpha.